Hello students, welcome back. In this video, we're going to introduce the core mechanic of Bot Bash Arena, and that is shooting bullets. We'll create projectiles that we can aim all over the arena using our mouse. This is going to give our little robot the ability to not only maneuver through our world, but also begin to cause some damage. So let's head over to the computer screen and we will dive right in. I have lesson 3's starter file open here in vscode.dev. I'm going to minimize this browser tab, and I'm also going to open that file directly. So we'll come over here to lesson 3, and we'll open lesson 3's starter file. Let's see where we're at. So right now, if I hit enter, I can move around. All right, so this is great. My overlays work. If I click a mouse button, though, I get no bullets currently being fired. So my projectile system, my aiming system, is not operational, it seems like. Well, that's all right, because that's what we are going to fix in this video. So let's look at Bot Bash Arena Lesson 3, our core mechanic of aiming and projectile weapons. Mission number 1, it says add the bullet speed and size values. So we are implementing a brand new system into our game, the system of projectiles. And typically when we introduce a brand new system, I always like to go look at the student edit zone. What are some of the constant variables we have that can control the new system that we are implementing? And if we look, mission 1 puts us right here for our bullet values. So here we have two constants that we can tune for the bullet system, the bullet's speed and the bullet's radius. So right now the speed is set to 1. That is going to be way too slow. So 1 pixel per frame, not happening. I'm going to give its speed 10 pixels per frame. And then we can test that later once we get the system in place. If we like it, great. If we don't, we just come back up here and we can tweak that value. Our bullets are going to be circles, so their size will be defined by a radius. A radius of 200 is going to be huge. The bullet would be like, this whole big. I mean, that big. Like, how big is our player? Our player's radius is 18, so that is, roughly 10 times the size of our player. That would just be comical and very bad. So we're going to make the bullets super small. So let's make the bullet radius, I don't know, I'll set it to be 3. And we can always, again, come back and change that if we want to. So now that we know the constants that we have, let's go look at what we might have for gameplay variables. So our color palette, do we add anything for our color palettes? Oh yeah, we add a bullet color, so we have that to work with. And then, all right, so here are our gameplay variables outside of the student edit zones. It looks like we have 2 new variables at our disposal for our game, and those are called bullets and shot cooldown frames. Let's talk about cooldown frames first. We're going to have our firing system be on a cooldown so that if the user is just holding the mouse button, it's not going to create an infinite number of bullets. There'll be some like cooldown. So like maybe we'll fire a bullet once every 2 seconds. So if I'm holding the mouse button down, it'll create a bullet, but then it will count down, 2 seconds, or I guess 120 frames here, until the next bullet is created. So we're going to keep track of that. And then we have this new data structure, bullets, indicated by these square brackets. This is called an array. And you can think of an array like a big old container that you can put objects in. And in this array, we are going to store bullet objects. And so right now, the array is empty. There's nothing in it. But eventually, we might have that array contain bullet 1, bullet 2, bullet 3, bullet 4. And if we want to do operations on each and every one of these bullets, instead of doing it 4 individual times, we can do it on the entire array. We can say something like, for every bullet that's inside of this container, do X, Y, and Z. And that's going to be a really powerful tool that we have at our disposal. One last thing before we leave this idea of an array or a container, every item that is in this container is at a position. This first position is position 0. The next is 1, then it's 2, and then it is position number 3. We call those positions indices, or the index of the element. So the index of bullet 3 is index 2. And that allows us to actually like reach in to the container. So my container is called bullets. I can reach in and grab the item that is at that specific index, just like this. So we'll see that idea quite a bit here in this video. All right, so now we have an overview of the bullet system. We know our constant variables, bullet speed and bullet radius, and we know our gameplay variables, this container known as an array, bullets, and our shot cooldown frames. So let's now take a look at what else we have here in mission number 2. Mission number 2 says, fire input. We are going to fire bullets while the mouse button is held. We're going to trigger the weapon system using mouse input. All right, so we're moving our character with W, A, S, and D, but we are going to fire with the mouse button, which is super cool. So before we go through and solve this mission, let's look at where we are at. We are in a brand new function called update weapon system. Where is this function being called from? Well, if I go up to the P5 default draw function, as long as our game is in play mode, we are updating our player, updating our weapon system, and updating our bullets. So we've got 2 new update functions here for our bullet system that are going to be called every single frame of our game. Now, that means this is happening every single frame of our game. It looks like we're starting by taking our cooldown and subtracting 1 from it. All right. And then we're asking a question. If false and, so we've seen or, the 2 vertical bars, and are these 2 and signs. Shot cooldown frames is less than or equal to 0. All right, so shot cooldown frames less than or equal to 0 means we can create a bullet, right? If we set it to 60 frames, we counted down, we subtracted 1, 1, 1, 1, 1 all the way until it hit 0. Now we're ready to fire again. But then we need this here. So right now it says false. Well, we want to check to see if the mouse is being held down. And when you ask a question with and, both this part of the question and this part of the question have to be yes, okay? So is your first name Mike and your last name Ermo? For me, my first name is Mike, my last name is Ermo, so yes, okay? So we got to figure out, is the mouse being held down, the mouse button? So we have a nice little variable that's keeping track of that. It's called mouse is pressed. All right, so we're going to check to see if the mouse is being pressed. That will return true or false, yes or no. And then we'll check to see if our shot cooldown frames is less than or equal to 0. And if it is, we're going to do a bunch of this stuff where it looks like we got some other missions in here. But let's just see if this creates a bullet for us. Let's just see. So I'll refresh the page. I'll press enter. Oh, look at that little guy. I held the mouse button down and it looked like it created a bullet. If I restart the page, all right. So, boom. It creates a bullet. That's the world's worst bullet. I mean, it looks cool. I mean, it looks good. It's a decent size. But when I fire, why does the bullet appear way over here in the corner? And why is it not moving? That's really bad. I want the bullet to originate here at the player, and then I want it to move. So if I click over here, I want the bullet to go zoop over here. And if I click here, I want it to go zoop over here. I got a stationary bullet that is not originating in the right location. So let's see what mission 3 is going to have us do. Mission 3 is putting us in a function called generate bullet data, and it's called bullet spawn. We need to spawn a bullet from the player's position. Okay, so yeah. If we look, we're not spawning it in regards to the player's position. It's almost like, and I can only spawn 1 bullet. Well, actually, I'm spawning lots of bullets, and they are just stacking up on top of each other because every single bullet is at the same location. If you look here, that location is 100 and 100. Before we get into this mission, let's look at how we implement new objects into our world. I have a function called generate bullet data. Then I have a function called spawn bullet, and I have a function called update bullets. And typically, anytime we introduce a new object into our world, we'll use these 3 functions to bring that system into the world. We'll have a generate function, a spawn function, and an update function. So in the generate bullet data, it looks like I create a variable called spawn x and spawn y, and those are in relation to the player's x values and y values, right? So the x and y. So figure out where your player is in the horizontal direction, figure out where your player is in the vertical direction, and then we're using those as spawn x and spawn y. So right now I have it hard-coded as 100 and 100 for the bullets x property and y property. I don't know, let's change that. Let's change this to 500 and 500. So now when I fire, where's the bullet going to be created? Well, X coordinate 500, Y coordinate 500. But I want to spawn the bullet wherever the player is at. So I'm going to use the variables that were created in this function of spawn X and spawn Y. All right, let's check this out. Let's see if this works. So now if I refresh the page, so I'm over here, I create a bullet. Oh, there it is. Okay. So now I'm over here, I create a bullet. Hey, there it is. I'm over here, I create a bullet. I can keep, whoa, and if I, hey, look at it, if I just hold the mouse button down, this is cool. This is kind of like a neat little game. This is a game all on its own. But there's a couple of problems here. So one, I should not be able to spam bullets like this. That's not correct. And then two, the bullets are always being created like down here, like down and to the right. I mean, if the mouse is up here and I click create a bullet, I want the bullet to be created up here because it's about to shoot this way. And if I click over here, I want the bullet to be created over here because it's going to be shot this way. So we somehow have to work with that. And there's something in this function that we'll allude to. We'll bring it up now that's going to help us. And it's this nx and ny, because we're taking in a couple of pieces of information, nx and ny. We got to figure out what is nx. We got to figure out what is ny. And we'll certainly do that in an upcoming mission. But just know that they are here in this generate bullet data. And that might help us figure out where, I gotta refresh this. That might help us figure out where we need to spawn the bullet. Do we spawn it here, 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 here? Well, it's all going to depend on where our mouse is, okay, where our mouse is. All right, and now let's just kind of look at where are we calling generate bullet data? Well, we're calling it inside of the spawn bullet function. So when we spawn a bullet, we're taking our array or container of bullets, which when we start our game, it was empty. And then we're calling the push method. And the push method basically takes and pushes an object into that container. And it pushes it right at the end. So right now, if my container is empty and I click the mouse button, when I click the mouse button, it should spawn a bullet. Let's just take a look. So here's where I clicked my mouse button in mission 2. We do a bunch of stuff, and then we call the spawn bullet function. So that's pretty good here. So we're calling spawn bullet. So spawn bullet gets called, and in here we're pushing into this empty container. There's nothing in it. Whatever is returned from the generate bullet data function. So generate bullet data returns this object. That object right there represents a bullet. It has an X position, a Y position, a horizontal speed Vx, and a vertical speed Vy. And so now we have bullet 1 in the array. I press the button again to spawn another bullet, and then we get bullet 2, and then bullet 3, and then this just fills and fills and fills. Awesome. So we have a good understanding here. Let's go see if we can fix this bullet system a little bit better, because right now making bullets is cool, but moving bullets is going to be even more awesome, because right now, boom, it is completely stationary. I want to see this thing whiz across the screen. And so mission number 4 is all about updating our bullets. It says move bullets using their velocity values. Update their position each frame. All right, so when we spawned our bullet, we saw that they had a horizontal speed, Vx, and a vertical speed, Vy. And we got that by taking our bullet speed, which we set to 10, and multiplying by nx or ny. So we still got to figure out what nx and ny are. We're going to get there shortly, but just know our bullets can move. They have a speed, right? It's going to be like, it's 10 maybe. And let's just assume nx is 1 and ny is 1. So 10 and 10. We just got to use those speeds. So if we look in update bullets, we are using something here called a for loop. And now this is really powerful. We had mentioned that when you have a container or an array of items, you can do operations on everything inside of the array. And the way you do that is with a for loop. So if we look at what we're saying here, we're saying for let I equal bullets.length minus 1, I greater than or equal to 0, I minus minus. That is a very complicated statement. Let's look at an array. So imagine here's my array, and I got bullet 1, bullet 2, bullet 3, and bullet 4. Let's just imagine that that's what I'm working with. And these are at positions. They have a certain index, 0, 1, 2, and 3. When we use a for loop of this manner, we are doing it in case we have to remove an element from the array. So removing elements. If you want to remove one of these bullets from the array, you will always loop this way. We are looping backwards through the array. So let's look. We're creating a variable called I, and it's going to equal bullets.length. So our array has a length. It has 1, 2, 3, 4 items in it. But 4 minus 1 is 3. So I starts at 3. That corresponds to the last element in this array, right? That's its index. And so if you look here, the first thing that we do is we say, hey, we're going to create a variable called bullet, and we're going to go into our array and reach in and grab the thing that is at index I. Well, if I is at 3, then we're going to go in and get this last bullet, and we're going to work with it. We're going to do all of this code in here for that particular bullet. Then we're going to come back up, and it says, hey, we're going to keep running this as long as I is greater than or equal to 0, and try subtracting 1 from I. So I was 3, we subtract 1, now it's 2. So we go through and we reach in and we grab the bullet at position number 2, and we do all the code. And then we get back up here and we say, hey, keep doing this as long as I is greater than 0, subtract 1. So I subtract 1 and it's 1. So now we grab this bullet and we keep doing it, and then we come back up here and we decrease, and I is still greater than or equal to 0, so we grab this bullet. And then when we go back up here, if we subtract 1 again, we'd be at -1. This is no longer true, so the loop stops. So this allows us to loop through an array backwards, and that's what we will do anytime we need to remove an element from the array. So I'm going to change this and not hard code the position that I want to grab at. I'm going to grab at position I. So now I have a bullet to work with, all right? And so what we're going to do is we're going to take its x value and we're going to increase it or change it. I want to change it by whatever the bullet's horizontal velocity is. So my bullet is the variable here, and they have a bunch of properties. They have a Vx property. So we're going to add to the bullet's position however fast they're moving. And we'll do something similar in the y direction. So we'll say, hey, the y position, let's add their vertical speed, bullet.vy. Doing this, our bullet should now begin to move. So let's take a look. I'm going to hit enter to start. I'm going to move around. I'm going to fire a bullet. Hey, look at that. It goes flying. And I can create just a stream of bullets now that are constantly moving. See, right now, there's like no cooldown. I can just keep creating these bullets. That's not really what I want to be able to do. All right, so but that's kind of cool. But of course, they're all moving in the same direction. No matter where my mouse is, they're not moving where I want to fire them, which is a huge bummer. But that's all right, because we have a few more missions. Let's look at mission number 5. Mission number 5 says, aim the bullets towards the cursor. Ooh, this is exactly what I want. I want that functionality. I want my bullets to finally start moving to where I am pointing. So mission number 5 finds us in our update weapons systems. So we have, let's see, we're decreasing our cooldown. We're checking to see if the mouse button is pressed. And then we do all of this wacky math. So there's quite a bit of math going on here. And to help us figure out how we are going to aim the bullets towards the mouse cursor, we are going to go to a whiteboard. I'm going to bring up a whiteboard so we can do just a little bit of math here together so that we fully understand what we are doing in this function. So to start, I'm going to draw a picture. Imagine here is my player. So let's see, here is my player. Okay, so here's my player. And then my mouse is right there. So there's my mouse. So you can see the player and the mouse are a certain distance away. We'll call that length, the length of this arrow that we are away from each other. I'll call it len. All right, so that looks pretty good. Now you can think this arrow has 2 parts to it. It has a horizontal part and a vertical part. That horizontal part can be found by just finding the mouse's x position right here, zoop, and subtracting the player's x position. And doing that, we get an arrow called, I'll call it dx. And I'll say, hey, dx can be found by taking the mouse's x property and subtracting the player's x property. Well, in the same regard, this arrow right here, our length, has a vertical part to it, right? Sort of pointing up and to the right. Here's the rightward part. Here is the upward part. And I can call that dy. And to find dy, I just take my mouse's y position, and I'll subtract the player's y position. So far, so good. Not too bad. All right, and so this makes a really nice triangle. In fact, this is something called a right triangle, and we can indicate some angle here called theta. And theta is going to be very, very important to us. So we know how to find dx. We just did it. We can subtract the x position of our mouse and our player. We know how to find dy. How do we find length? Well, the length here can be defined as the Pythagorean theorem. So there's something called the Pythagorean theorem, which says, hey, if you have three sides of a triangle, and I'll label these sides, let's label them A, B, and this longest side of our triangle, we'll call it C, is known as the hypotenuse. The relationship here is that if you take A and square it, and then add B squared, you get C squared. So let's substitute in what we have. We have dx squared, that's our A side, which we know how to find. We have our dy squared, that's our B side, which we know how to find. And that's going to equal our length, which is how far away we are from our mouse, squared. But I don't want the length squared. I want the actual value of the length, right? I don't have like, I solve for dx, I solve for dy. I want to solve for length. So to get rid of the squared here, I take the square root of this side, and I take the square root of this side. And that tells me the length, or how far away we are from our mouse and player, is dx squared plus dy squared. All right, so now I know how to solve for the length. I know how to solve for dy, and I know how to solve for dx. That's really, really important when we talk about movement, collisions, and tracking. So those three values in this right triangle are really great. But that right triangle can sort of change. So now imagine my player's here. Okay, so here's my player. And now my mouse is not sort of like up and to the right. Maybe it's a lot to the right and only up a little bit. So now you can see we still have this length arrow. Zoop. Okay, so there's my length arrow. But if we look at like here, like my dx and my dy arrows, they're sort of like almost the same size, right? Here, my dx, actually this picture was drawn pretty poorly. I'm going to redraw that arrow. Let's redraw that arrow so we see it a little bit clearer. So here's my player, and I'll put my x property here. So here is my length. Like this arrow, our length here has a much bigger horizontal part than it does over here. Much bigger dx, and a much smaller dy. And so we can define that by some angle theta. We know how to solve for dx. We know how to solve for dy. We know how to solve for length. Now the question is, how do we get these angles theta? Well, there's two trig functions that will help us with this, and they are called cosine and sine. And so there's a relationship that the cosine of theta is equal to the adjacent side of your triangle divided by your hypotenuse. And the sine of theta, our angle, is equal to the opposite side of our angle divided by our hypotenuse. So this is going to tell me that, hey, the cosine of theta is equal to, in either triangle, the adjacent side is the side where you swing down. So right here, dx, over our hypotenuse. Our hypotenuse is the longest side. That's our length. And so dx divided by length is equal to the cosine of theta. And you can think of the cosine of theta as essentially how much of the arrow of len is in the x direction. Right? What percentage of that arrow is in the x direction? Here you can see a big portion of x is in the x direction. Here you could see a smaller portion of that arrow is in the x direction. Well, a similar analysis can be done for the sine. So now I have the opposite of my angle divided by my hypotenuse. The opposite side is dy. Opposite side is dy over here. So I can say, hey, the sine of theta is equal to dy over my len. And that sine is essentially how much of len is in the y direction. And so if we look over here, it's small y value. And over here, it's big Y value, a bigger Y value. And those amounts of X and amounts of Y are going to allow us to essentially determine where the mouse is in relation to the player. So we're going to use this dx divided by length and this dy divided by length. So that hopefully gives it a little bit of context here. So if we look in our update weapon systems, what are we doing? Well, anytime we fire a bullet, we're getting our dx value by subtracting our mouse's x and our player's x, our dy by subtracting our mouse's y and our player's y, and then figuring out length using the Pythagorean theorem. All right, so that's kind of like that math right there. So that looks really great. And then we're saying, hey, if that length is almost 0, if it's like less than 0.0001, just return, get out of this function, because we're clicking right on top of the player. Let's not create a bullet if that's the case. Otherwise, it says, hey, let's aim our direction. We're going to aim the bullets towards the mouse cursor, calculate the firing direction from the player to the mouse. So if we look here, if I'm over here, I want to figure out this length arrow that we could kind of just draw out. How much of it is in the x direction? How much is in the y direction? If I'm over here, how much of the length arrow is in the x direction and how much is in the y direction? Well, in order to get that, we're going to use the cosine of theta and the sine of theta, which are right over here. So I'm going to do dx divided by length, and we'll call that nx. All right, so dx divided by length. And to get ny, the portion of that arrow that's in the y direction, I'll do dy divided by our length. And so we've seen nx and ny pop up a bit here in some of these functions. They were previously just set to 1, basically saying like, hey, all of it's in the x, all of it's in the y. But now we're actually getting the correct values. So if we refresh the page, now when I click, ooh, I actually have tracking. Whoa, that's super cool. I can actually move it looks like I'm firing cheese balls all out of the arena. Very, very good. So I think, the direction here is working nicely. I can aim now, but I don't like that there is almost no cooldown. So let's go see what mission number 6 has us solving. Oh, good. Mission number 6 is having us add the weapon cooldown timer. So we saw that we have a cooldown here, but I don't think it's set. Because if we look, we have a constant for the cooldown system called fire cooldown frames, and right now it's set to 0. So it says, our cooldown is going to be 0 frames. We can fire basically every single frame, which is why we get like unlimited bullets. We don't want that. So let's set the cooldown to be, I'm going to set it to 11 frames. So every 11 frames, we have to wait to fire again. And so if we go down to like update weapon systems, let's see, shot cooldown frames. Right here, after we fire, we're taking that variable, shot cooldown frames, and we're setting it equal to 11. Think of this like our countdown timer. And so then at the beginning of our update function, we're taking that and we're decreasing it by 1. So 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. And when it is less than or equal to 0, that's when we can fire again. So right now, here I am firing like mad crazy. And now if I restart, I'm firing much slower with 11 frames in between each one. So now I got a bit of a cooldown, which is exactly what I want and how I want that to operate. So mission number 6 is in the books. That makes it a much more feasible system, right? It makes more sense. Now, mission number 7, we are, believe it or not, we're making a mess. Mission number 7 finds us back into update bullets. We were already looping through our array of bullets, our container, looping backwards because we want to eventually get rid of bullets. Right now, we are not getting rid of bullets. So as I fire these bullets, those bullets, they're just going off the screen and they still exist. They're traveling over here, off the monitor, through my wall, into my house. Well, not really, but they are building up in our computer's resources, right? Each one of these objects is currently being tracked. What we want to do is once they leave the screen, we want to make sure we kick them out of the array. We want to get rid of them, delete them so that they don't just keep building up in system resources and then that container doesn't get infinitely big. So right now we are asking a question that says if false. False is always false. That is always going to answer no. But we want to ask a question that when it is yes, we call that container or that array bullets, and we're calling the splice method, which means go remove something at a given position. So remove a bullet, and we're going to remove the bullet that is at position I, which is the current bullet that we're working in. And then the second number is starting at that position, how many bullets do you want to remove? We just want to remove 1, so we'll put a 1 there. Now, we just got to figure out when do we want to actually remove our bullets? Well, we want to remove our bullets once they leave the arena. So I don't want a bullet like traveling over here. So if you remember, we had gameplay variables called arena left, arena right, arena top, arena bottom, all those good things. So let's just put bullet. I'm going to grab the bullet's X property. I'm going to check its X property and see if it's less than arena left. Let's just do that one right now. So right now, if I shoot up here, they're going into the HUD, they're going down, they're going off the screen. But if I shoot to the left, hey, look at that. They're dead. They don't come over here because we're now splicing them out of the array. So now I got to put similar checks. I'm going to put a similar check for the right. So let's just check. So I'm going to say, hey, if this is true, or if the bullet's X property is greater than arena right, tab for autocomplete. So now we can remove them here and remove them here. That's great. But now we got to take care of the top and the bottom. So our Y values. So let's do the Y values, or bullet dot Y is less than. So remember, let's see, if it's less than, this right here is like our lower values, right? So we want to say if it's less than this, the arena top. So less than arena top, tab to autocomplete. And then I'll say, or bullet.y is greater than arena bottom. And I'll do tab to autocomplete. So if any of those 4 things are true, we are going to remove a bullet. And now we're cleaning up after ourselves. So our bullet system, our weapon system, now our bullets don't leave the arena. All right, perfect. That is wonderful. I think we just got one last mission here. And that one last mission, let's go take a look at what it is going to add a little bit of visual flair for our weapon system because we are aiming, right? Our robot is aiming its bullets. What I want to do is have its eye sort of follow where the bullet is going. Its eye should track the mouse so we can look to see where we're aiming. And this puts us inside of our draw player function. So here's where we're drawing everything about our player, which looks really great. And now we want to get to eye tracking. So we're going to make the player follow the cursor, use direction to offset the eye position. All right, so how are we going to do this? It's almost like the player needs to know where the mouse is, right? The player, we need to know where the mouse is. So like if I'm pointing here, there's an arrow from the player to the mouse. I want to know like how much of that arrow is in the X direction and how much of the arrow is in the Y direction. Because as I, maybe come this way, we're decreasing the amount that's in the Y direction, and we want to sort of follow that change. Well, if we look here, we've already kind of done this, and we've talked about nx and ny, right? Essentially the cosine of our triangle and the sine of our triangle. And I'll pull that up right here again. It's how much of the length arrow is in the X direction and how much of the length arrow is in the Y direction. So we got to use nx and ny here when we position our variables ix and iy, because right now ix is just set to the player's center X value and iy is the player's center Y value, and we're drawing a circle, and circles take in 3 pieces of information. They take in a center for the X, a center for a Y, and then the diameter. So we want to maybe sort of offset where we're drawing the center of our circle. So, for example, if I just add can I just add 5 to these? I don't even know if this is going to work. Let's just see. If I add 5 to these, does the player's eye position change? Yeah, look, they're now looking down here, okay? And so I want to add something that's constantly going to be changing though, and it's going to be changing in the X direction based on nx, that variable nx, how much of our arrow is pointing in the X direction. And then I'll add ny in the Y direction, how much is pointing in the Y direction. So let's look now. Hey, our eye sort of tracks. That's not bad. Of course, it's super minimal. So what I want to do is I want to increase the effect of this nx and ny. And the way I can do it is multiply nx by a number. I'm going to multiply it by 4. The bigger the number here, the bigger the effect you're going to have. So I'm going to multiply it by 4. And now what we're going to see is instead of just moving in a little tiny circle, we're going to move in a bigger direction. Let's take a look. Do we get some nice eye tracking? Oh, yeah. I really like that. That looks super, super cool. So now the player is looking, our little robot is looking where they are firing, and we have really nice mouse tracking set up. All right. I think this is a great place to stop. Our weapon system is fully functional. Not only are we firing projectiles on a cooldown, we're cleaning up after ourselves, but we've implemented some really cool tracking. So our mouse, as we move our mouse cursor throughout the arena, our robot aligns itself. It looks to see where we are, and it fires our bullets in that direct location. We'll continue to build on this system coming up in our next video. So I'll see you then.